All right, so this will be more with arithmetic series and using sigma notation to get the sum of a bunch of terms. So let's start out with a kind of a word problem here. Let's say we want to read a book, 645 pages in the book. We want to do this in 30 days, and each day you want to read one more page than you did the previous day. So how many pages should we read on the first day? Okay, so let's think about, okay, you're going to be reading some amount of pages, day 1, day 2, day 3, all the way out, 30 days. And we want the sum, you want to read the whole book, right? So we want to read 645 pages in total. Okay, and the pattern is that you will read one extra page a day. So if you start out reading 6 pages day 1, you'll read 7 on day 2, then 8 on day 3, and so on. So we have this pattern which makes this arithmetic of a +1 common difference. Okay, and our question is, how many pages should you read on the first day? We need to know what a starting point, right? So that's what we call A1, the first day. So let's see if we can get this figured out. So we want the sum to be 645. Okay, and since this is a pattern of adding one additional page, that makes it arithmetic. So the previous video on arithmetic series said the formula for the sum of n terms is always n/2 times the first term plus the last term, a sub n. Okay, so in this example, we know we want that sum to be 645, so that's s sub n. Okay, we know how many terms there are. We want to do this in 30 days, so n is 30. Okay, A1, that's the thing we want to find, so we don't know that yet. Now, do we know how many we want to read on the last day, a sub n? We don't know that either, right? So that's kind of unknown as well. So it seems as though there are two unknown things in an equation, and we can't really solve with two variables. So let's dig into this a little bit, and let's think about a formula for a sub n. Okay, since it's arithmetic, we have an explicit formula that's always a1 plus whatever the common difference is times n minus 1. Right? That's an explicit formula for a sub n for the nth term. So let's think about, we don't know a1. Okay, d, the common difference, that's what this +1 is. That's d. And then we actually know how many terms there are also. We know there's 30 terms, so that's n. So what we can do is just kind of do a little simplifying here and get a1 plus 1 times 30 minus 1, so 1 times 29 is just 29. So what I can do is take this guy and plug it into the formula where an is and see if we can work algebraically to get this thing solved. Okay, so let's do some simplifying. So 645 equals 30/2 a1. Here's my substitution. Instead of an, I'm putting a1 plus 29. Okay, that was the substitution from right here. So now it looks like there's only one of missing term, right? A1, we don't know. It's only one variable, so we should be able to solve that algebraically by doing some simplifying. So 30/2 is 15. If you notice in the parentheses, there's a1 plus another a1, so that's 2 a1s plus the 29. And we should be able to work through this and solve for a1. So doing the algebra, I'm going to first divide by 15, both sides, get rid of that. Okay, so dividing by 15 should get us, let me double check, I don't have a calculator on me, I think it's 43. Yep, 43. So 43 equals 2 a1s plus 29. And then we'll just do a couple more steps. We'll subtract 29 from both sides. Because remember, we're trying to solve for a1 here. So that should get us 14 equals 2 a1s. And dividing by 2, we'll get our answer, a1. So we should be reading 7 pages on day 1 in order to get this book finished in 30 days. Okay, and just to kind of visualize, what we're saying again, 7 plus, if you read 8 the next day, then 9 the next day, then 10, and so on. If you did that for 30 days, that's how you could get up to a sum of reading the entire book of 645 pages. Okay, so kind of interesting how that works. Okay, so that was an example using the formula in a different way. Now there's one other, there's a symbol that can be used to do sums, and you may have seen this in other applications somewhere, but basically this Greek letter here, sigma, um, chances are if you see that somewhere in a math class, it's going to represent a sum, meaning add up a bunch of terms. Okay, so it's just a shorthand symbol for that. And then what's given here, they give you a few things. They will give you, this is called the general term, or basically what it is it's the explicit formula for the pattern or for the sequence. Okay, so that's how you would get the terms of the sequence, by plugging into that. And they're going to have to tell you how many terms they want the sum of. So down here, the lower limit's basically like the starting value. We're going to start out when x is 1, and then we'll go x is 2, x is 3, x is all the way up to this upper limit is going to be like the highest value of x that we will plug in. Okay? So the long way to do this is what I was just saying. Basically plug in 1 for x, then plug in 2 for x, then plug in 3 for x, then plug in 4 for x, get those values, and then add them all up. Okay, so let's just show that way because 4 terms isn't really too bad. But you can imagine if this upper limit was like 1,000 or something, you're going to want a faster way to do that. And there luckily is. But just to show it in this case, if x were 1, if I plugged in 1 into that explicit formula, it'd be 4 times 1 minus 3. So 4 minus 3 is just 1. And then I would plug in 2, and you really just kind of use consecutive numbers here. So 8 minus 3 would be 5. Then you plug in 3 for the x. Okay, 12 minus 3 would be 9. And then we plug in the upper limit, which was 4. That's where we're going to stop. So 16 minus 3 would be 13. And then the sigma part just means add all of those up. So we would get a final sum. This thing would equal 28. Okay, it always has a numerical value. Okay, so that's really what's going on. Just to verify that answer using the formula from the previous video, and then I'll kind of walk through this calculator trick to do this. Okay, from the previous video, we showed about the sum of an arithmetic sequence. And if you look at this, these numbers, this 1, then 5, then 9, it definitely is arithmetic. We have that common difference of 4, which basically is like the slope in the explicit formula, right? That's the common difference. But just to verify we can get the same answer, we were finding the sum of the first 4 terms, right? That was our upper limit. And what the formula says is just n over 2, so 4 over 2. And then it's always the first term, which was 1, plus the fourth term, which was 13. And we should verify algebraically that this thing is going to get us 28 as well, right? Because 4 over 2 is 2. The 1 plus 13, of course, is 14. And 2 times 14 definitely gets us the same sum we got before. Okay, so remember, to use the formula, all we really needed was that first term and the last term. You didn't necessarily have to do all the work of getting these middle terms here. I just showed that the first time because that was like literally what this question's asking, but it was a little bit lengthy of a process, and it could be, again, if there were a lot of terms, that wouldn't be too fun. Okay, but here's kind of a real trick to use your calculators to do this stuff. Let me show you where it is. You can see it. You can actually type it in just like it looks on the paper. As long as your calculator has the updates. I think most of them do. But you're going to go to Math, and then press up. It'll take you to the bottom of this list. A lot of commands. There's one summation, or it may just say sum on some calculators. Now, some of them don't look like this exact format. You have to type things in a different order and whatnot. But with this software, this system, I'm just going to type in, I use X for the variable, and then I'm just going from 1 to upper limit of 4. Okay, and then right in there, you can just type in the explicit formula. Make sure you use the same variable that you used originally, and that will actually do the sum for you really quickly. Okay, so this can be used to find any sum. If you know the explicit formula, okay, and you know the how many terms you want, you can use this to do the sums of anything. Okay, or for geometric, arithmetic, any type of sequence. Actually, you can type in the explicit formula. Okay. Now, when you're doing these, it pretty much always starts with the first term. There may be a case where you need like the sum of the 5th through 20th term or something. You might have a lower limit not be 1, but again, pretty much all the applications we'll see, at least at this level, are going to start with the first term. Okay, because that's what the formulas are assuming. You know, when you use this kind of formula, it's assuming you're doing the first n terms. Okay, so finally, one last thing just to kind of work backwards. Let's say we had this sum here, and we just want to see, you know, what would be a shorthand way to write that as sigma notation. So we can kind of take a look, and we know it's going from, I usually use x. You can use n if you want to. The calculator uses x, though. So from x equals 1, now we have how many terms? Okay, there's a first term, second term, third term, fourth term, and fifth term. So we have 5 terms. That's going to be your upper limit. And all we need to do then is get an explicit formula for the pattern to go right there, and then it'll be sigma notation. Okay, so this will be a review for a little bit of explicit formula. The pattern between terms is arithmetic, right? Because we have that common difference of plus 7. So the explicit formula of the sequence, a sub n, if you remember, is always, I'll just write this out as a review, it's always a1 plus that common difference times n minus 1. Okay, so for this example specifically, it would be 8 plus the difference is 7 times n minus 1. Okay, and you can throw that right in the parentheses there. I'm gonna simplify it by distributing the 7. So 8 plus 7n minus 7, and then combine the 8 and the minus 7 to be a 1. And I'm going to take that 1 plus 7n, just throw that in right here. Okay, and that would be sigma notation, which if you threw it into your calculator would get you the exact same value as whatever these numbers add up to. Okay, so just a couple options. So feel free to use sigma notation to do any of the sum problems, and it should help you out and save some time. All right.